lecture series on steady state stability analysis. How previous lecture on construction and numerical on the Clark's diagram? It was truly wonderful experience of drawing Clark's diagram on graph paper, wasn't it? Okay. Today we are going to have an interesting discussion on the heart of the system stability studies, that is the power angle curves. The question based on this concept may ask in your university exam in the form of short note carrying 5 to 7 marks. Okay, so let us start. The theory of steady state stability of circuits with resistance is complicated by the following facts. First, we will discuss why the steady state stability studies become complicated when we are considering the resistance in the circuit. There are two reasons. The first one, maximum power at the sending end exceeds the maximum power at the receiving end and occurs at a different angular separation of the two machines. That is, this is our today's topic of discussion, that is the nature of the power angle curves for different cases that we will see later on. And the second fact is that the maximum stable angle depends upon the relative inertias of the machines and upon the governor action. So let us consider the first one. So for considering the first case, we are considering the different power angle curves for the cases as shown here. Case 1, the power angle curves of two machines connected through series resistance and inductive reactance. This is clear from this diagram. This is machine 1 and machine 2. Rather, we call this as a generator and this as a motor. It is connected through this resistance and inductive reactance. The power angle curves of this case can be plotted as shown here. If I plot power versus delta, I can draw the power angle curve for the generator side as P1 and the power angle curves for the motor side as P2. Okay, maximum output of machine 1, that is generator, occurs at delta is equal to 180 degree minus theta 1 2, which is equal to, I call, delta M1. And maximum input of machine 2, that is motor, occurs at delta is equal to theta 1 2, that is equal to delta M2. What is this theta 1 2? Theta 1 2, as mentioned here, that it is the angle of the architrave impedance. Architrave impedance means this branch impedance. I call this as the architrave impedance. Okay, so it is the angle of the architrave impedance. If this impedance consists of pure inductive reactance, obviously theta 1 2 will be what? Can anybody tell me? True, it is 90 degree because of pure inductive reactance, and both maxima occurs at delta is equal to 90 degree. Both maxima, that means the maxima for P1, that is for the generator side, and maxima for P2, that is for the motor side. Both are occurring at delta is equal to 90 degree. Okay, now for this case of two machines connected through series resistance and inductive reactance, theta 1 2 is less than 90 degree. It is true because of the presence of resistance. Now theta 1 2 is less than 90 degree. Then maximum occurs at a value of delta greater than 90 degree and maximum received power at value of delta less than 90 degree. The power angle curves for this case are plotted as above. The loss in the line is also plotted versus delta as shown here. Is it clear? Here the P1 for the P1 occurs at delta M1, which is greater than 90 degree, and maximum of P2, that is for the motor side, which is occurring at the delta M2, which is less than 90 degree. For the case when this is the series reactance consisting of the resistance and the inductive reactance, right? This was the case 1. Now let us consider case 2, that is power angle curves of two machines connected through reactance with an intermediate shunt resistance load, that is the type of the negative resistance. Okay, as shown here, right? So the power angle curves of this case can be plotted as shown in this diagram. This is for P1 obviously for generator side, this is for P2 for the motor side. Now delta, what you observe here, this delta M1, the maximum power for the generator side occurs at delta M1 which is less than 90 degree, and the maximum power for the receiving end, that is on the motor side, it is occurring at the delta M2 which is greater than 90 degree. Okay, so here if I reduce this T circuit to the pi circuit, what I obtain when the T circuit of the shown there is converted to pi, the architrave impedance is, it is obviously you can solve this, okay, by network formulas, that is jx plus jx plus jx upon r. So I got this expression, right? The real part of which is negative. Due to this negative real part, we can observe the such kind of nature of the power angle curves. So what will be the conclusion, that here with negative resistance and inductive one2 lies between 90 degree and 180 degree. Consequently, maximum sent power occurs at delta less than 90 degree and maximum received power at delta greater than 90 degree. The power angle curves for this case are given in the above figure. The power consumed by the load is also shown, right? So, considering all these cases, we can conclude that with either series or shunt maximums, the maximum received power is than maximum sent power, and this is true because of the presence of resistance. The losses are occurring in the system, therefore the maximum received power is less than maximum sent power, right? This is for the concept for today's concept. Now I would like to give you one simple small assignment, that is write a short note on effect of governor action. Okay, and I would like to all of you have to submit this on our Google Classroom till coming Saturday, that is up to 5th April 2020, right? Okay, so that's all for today's session. Thank you.